I mean, I took a statistics class
Okay, so you've seen it at least.
20 years ago.
You remember how to calculate, when you flip a coin, what's the probability of getting heads?
Yeah, I know
Like,
a little bit. I
it's
know there's some of the
50%.
basic concepts.
Yeah, but we call it 0.5 because probability is a fraction.
Uh-huh.
So, or if you flip a roll of die, the
Right.
probability is 1 in 6, that sort of thing.
So I wanted to let you know.
Okay.
So the video.
Oh, yeah.
So the video was okay, but in reality, when I went back and I was trying to like do stuff, to like redo stuff.
Yeah. Couldn't see what was on the screen, so.
Like this is the screen for the last 25 minutes.
Yeah,
or
we were
45
just
minutes.
talking. Yeah, you can see it.
And I can't. So like ideally, I mean for you, like to help your students,
Yeah, you need
you
the
might want to
screen.
have a screenshot of walking through doing stuff on the screen, and then
Yeah. Well,
That
I
would-
want to capture both. That's my plan, but I haven't got that working out. So
Yeah.
right now I'm stuck with
because I'm still like not even able to. Like I pull up this and I pull up this and I save this and I try to pull it up on here and then it doesn't go. So
Alright. Well, let's start with that part then.
I'm just trying to get through the first page, literally.
Okay.
And I'm sure, obviously, you know, I forgot stuff along the way,
Well, yeah.
but it seemed simple enough at the time. And I'm not stupid. I'm not a genius, but I'm not an idiot.
Not the way you're used to
Nothing wrong
using
with that,
a
but
computer, though. That's
I should be able to get it in the first month.
Yeah. I think you'll get it. You'll get it after today, because I think you basically know how to do it. You're probably just missing some little something.
Well, so what I did is, so I just started this.
We had the team viewer working okay last time, right?
Yeah.
Yeah, let me just start that so I can see you.
I started, so I'm looking for like online stuff, classes.
Is that gonna work? Oh yeah, did we have a problem with this last time, didn't we? Cursor on that. Okay. Let's see. Yeah. So you got.
So I bring up this, I
That's
named
the
it
code.
JJ,
Yeah. That's your,
saved it, typed in print hello, saved it, come down here. Already,
How did it get to here?
I logged in
okay.
Python. I thought I typed Python first, and then it brings that.
Yeah. So what you're looking at, it's not, because there's so much stuff going on here, it's not obvious, but the prompt that ends in a $, that is your Apple computer's terminal prompt.
Mm-hmm.
And from there you can type in Python and then the name of the file, which was jj.py.
So I did that.
But you're not at that prompt. After you've run the Python, you get a different prompt, which is this 3 greater than signs. So this is your system. This is inside of Python. So you can't ask to load Python when you're already inside Python, because you're already in there. So even though it looks really similar, you're not at the same kind of command prompt. It's almost like you're sitting at a different type of a computer. You can quit this. So to get from there back to the system prompt, you can do Control D, I think. Not that Control D, maybe that Control over there.
Oh, right.
Let's see. Try it one more time. There. And notice you're back to the $sign prompt, and then from there, you can type in Python and the name of the file, but you do have to be in the right folder as well. And so so it's saying the file isn't there, and the reason is because the folder that you saved the file in is a different one than the one that you're sitting in over here.
Okay. So
it won't seem like a big deal once
I
you
save
get
it
used to
as.
Yeah, so you need to know where you are over here, and one way to learn that is to type in ls. So at the system prompt, type in ls to see what you have. To see the contents. Yeah, and so you're in a folder that doesn't have.
Well, I'm in the Python folder. It should be in the Python folder. It should be that we saved. We created a Python folder.
Yeah, but the terminal, when you start a terminal up, it always starts in the same place, which is the user's home. And so within there, there's your desktop, your downloads, your different things. And so you had to do, remember, the series of commands to get started. So from the $sign prompt, you do the ls to see what's in there or where you're at.
Yeah.
And then you need to go into desktop. So you do cd space and then
CD.
Yeah, cd means change directory, and then space, and then you'll type in desktop with an uppercase D. Oh, but it didn't care. Okay, it's period out anyway. Good enough. And if you type ls again, now you'll see what's in the current folder, and that should match what's actually on your desktop.
Right.
And now you see the Python folder, and so to get into the Python folder, same thing, you have to do cd space Python.
Say CD space.
CD, change directory space Python.
So why Python there? Like.
It's a different Python. Yeah, we can name it something different. It's just a folder called
That's the
Python.
folder?
Yeah.
Okay. Yeah.
So these are just the basic concepts. So once you get past it, it won't seem like that big a deal.
Project, massage here, Python. Okay, so in change directory to the Python directory.
Okay, and then if you type ls again, which you don't have to do every time, but it always shows you what's there. Kind of orient yourself. Now you see you're in a folder that has all these Py files. And you can run any one of them now.
Alright.
But you got to type Python and then space and then the thing you want to run. The Python now is actually activating the Python system and telling it to run that particular file.
Okay, so finally did it.
Yeah, so that one worked.
Okay.
That's just something you got to get used to.
Yeah.
I did send you this piece of paper with these steps on it, I think, the last time.
Yeah.
But I'll write it down again one more time. $sign, ls, cd Python, cd desktop, cd Python, and then it should be Python, and then whatever the name is, jj.py. And you get to the $signs are not what you type in. That's just so you know where to type it. The $signs represent the prompt. See how it says it's all that stuff, but it ends in a $sign? That's the thing that it's there to let you know where you are and who you're talking to. Okay. So you weren't able to run anything, so I guess you didn't get to actually play with the code any. But we'll take it a little further today and have you try it one more time at the end from scratch to make sure that you definitely got it.
Great.
And this, you're getting into the back end of the computer. You know, most people don't ever open up the hood on the car and most people couldn't deal with it if they did. So there's gonna be some old stuff like this.
Yeah, and I'm like, can't it just be easier? Like, why can't?
It's because it's for a programmer, and they don't need it to be easier.
Like, can we create our own Python? What?
You can, yeah. There are ways that I could have made it so you wouldn't have to do those series of steps, but you have to get past this level anyway.
Yeah.
To get into doing the stuff you want to do. But we will. I mean, that's what I was trying to get at with the emails. That I'll look for ways. There's no need for you to get into the most complicated program. You want to do something powerful.
No, and just real quick, I pulled up this
to do that.
this thing called EDX. I was looking on. Anyway, it looks like they have got a lot of great classes.
I had a student
and
that's done 2 of those. Yeah, you can get a certificate.
Yeah, like, because that's where I'm headed with this. I want to.
So you got something to go.
I want to be working. I want to do this for work someday. So anyway, yeah, I'm just letting you know that this is what I'm doing, just in case you do or don't have anything to say about it. I'm just still like in the first few
I like it though.
Steps.
Did they say anything about the prerequisites for it, or?
It
But it's called CSMM.101X. Huh. I'll check it out.
Course overview. I'll need to know Python to be doing this work, but this is.
It's at your own pace.
They're like you're learning how to run AI programs in this, from machine learning to
good. This
to
is
games. Yeah, they have the Markov decision process that they're going to go through. So anyway, there's projects and
great.
tests.
We'll have an application for that.
Yeah, discussions. Yeah, so it looks pretty thorough. So anyway, I'm excited about it. This is what I'm doing in between, like seeing you. I'm working on some good classes that I can get into.
And you're able. It's free unless you want the certificate.
Yeah, which I plan.
Probably
when I get some money, I'll just do it.
But you can go as far into it as you want, and then decide to pay for the certificate.
Yeah.
Okay.
It's like $200 for an AI intro certificate.
Yeah. So do you want to start into that Markov process? Because that was one of the things I planned.
Yeah, whatever.
To discuss today.
Whatever. Yeah, because
you might not be able to get to that part of the class for a little bit because you need to be able to do a little more Python and more some of that stuff.
But yeah, and I can pick up I can pick up the concepts pretty well on my own. So anyway, this I'm excited about, kind of like it, because I love philosophy. So that was easy for me because I loved it, and this is similar to me. So it's like I like hanging around just watching videos and learning about how to do the background and the concepts. So I can definitely I'll be doing a lot of that on my own.
So yeah, even though I'm going to be kind of learning some of this stuff along with you, because even though I have a lot of programming experience, I don't really specialize in AI. I'm just really interested in going further with it. Anyway, so
like I was thinking today, it would be cool to be able to connect an AI to a motion detector. So when you walk in the room, the computer comes on and says hello.
Yeah.
Like something simple, like something like that should be kind of simple.
Yeah.
But it would take some.
I have this thing I'm imagining for this building. I'd like to be able to use the phone, because the phone knows where you are, and I want it to be able to detect that I have walked up to my door, because I have a path. So if I walk the path up to my door, that means I want to come in, and so I want the door to unlock itself, and I just walk in. No keys.
Yeah.
Right? And the same way with the garage door. Why didn't it just open when I approach? It opens as me. Yeah. And the front door. And that'd be so nice. And then the doors will open for my students by detecting your phone, and you're on my schedule. Now it gets more complicated.
Yeah.
But people are going to be doing it. So.
It's marketable.
So let's see. Yeah, there's some ideas in this process that you'll need to know as you get into the class anyway. So one of the concepts in here, let me make this bigger. See a little better. One of the concepts we'll see in here is called state. And the states will be represented on this drawing I'm going to make by things like S1, S2, and S3. And a state is a description of where you are, how fast you're going, and what you know. It's really a complete description of you. So right now, your state is you're in that chair. I'm in this chair. If that was all we knew about the world was those states, maybe you could be there, here, and there. Your state could be described by one of 3 different things. Because we're as humans, because you have so much information in your head, your state is actually very complicated. But we're going to draw a model that has a simple state. Okay. The other thing that we have is decision. And that's what AI is all about. You were saying like you'd like to, when you approach a motion detector, well, it would make a decision though. It would say there was a motion, and that means the person that matters is here. It would differentiate that from the motion of a dog, because you wouldn't want to talk to the dog. So there would be a decision process in there. Anyway, so decisions on here I'll represent with letters in boxes. So these are 2 different decisions you could make, choices. And then we'll have probabilities, and we'll have on there, well, we'll have rewards. And the rewards will be represented by like a curvy line with an arrow coming off of it and a number. So that indicates that something happened that gave you a reward of 5. So a positive reward would be thought of as a good thing. A negative reward is something you have to pay or some negative consequence or whatever. Okay, so the idea is that we're gonna, and they compare this to video games a lot, but you can compare it to whatever you want. We're going to imagine going between some states. So say I'll put state 1 here. Yep, put them in circles like that. And I'll put state 2 over here. And I'll put state 3 over here. Okay. And then we have to think of ways to transition between the states. And it doesn't especially matter what the states represent. So say in getting out of state 1, I can make a decision A, which could represent anything. So keep this one simple. Let's say decision A comes out of state 1, and if you make that decision, it takes you to state 2, and when you do that, you get a reward. We'll call it like 1. So if you're in state 1, that seems like a pretty simple decision. I get a reward, I might as well do it. Unless there's something bad about being in state 2, of course. And so when you get into the models, it becomes about looking at decisions many states deep, because it might be great to go and rob the bank now, but that might leave you in a bad state, even though you get the immediate reward. Decisions, however, can also be something like maybe coming out of here, I have also a decision A, which might take me to state 3. This is a different decision A because it's coming out of a different state. So not the same choice. Perhaps it has no reward, but, and here's the thing that's a little harder to understand, I declare that it has a probability of 0.9. So you remember that probabilities have to add up to 1?
Mm-hmm.
so there's a 0.1 missing. So you make decision A, and so what happens in real life is you make a decision thinking, oh, I know this decision will lead me there, but a certain fraction of the time it doesn't, it leads you somewhere else entirely. So we have to deal with the other 0.1, and let's say the other possibility, if you make decision A out of here, takes you back to state 1, and so the probability of that, if I want to complete it, has to be 0.1. But let's say it has a negative reward, -2. Now that makes things a lot more complicated, because when you get into state 2, you clearly going to want to move along. This doesn't cost you anything, but you take a risk of a -2. But it's only a 0.1 risk, and you can kind of do the math pretty easily. This would still be worth it if you can now get out of state 3. And then we could go in and make things even a little bit more complicated. And have multiple options here. Maybe I also have decision B out of state 2. And maybe it has a probability of 1, and it takes me right back to here. That seems to be better, because then I could just get the reward over and over again. But maybe it also has a negative reward, let's say -0.5 or something. That still seems okay. I could go around this loop repeatedly getting 0.5. But if I could go around this way, I can get 1 every time. And you have other constraints. You have time limits, and maybe you can only make so many decisions, that sort of thing. Anyway, so you can see where I could continue out building this type of model.
But yeah, and I'm not sure how to translate that into the code.
Yeah, that's the reason I wanted to bring it up now, is that at some point, you're not ready to do that yet, but at some point we're going to try to code something like this.
Yeah.
In Python, and we'll make it as simple as possible. You don't need a whole bunch of states and a whole bunch of decisions, but you do have to, what it comes down to is, well, how are you going to make the decisions? And that's what you'll see will come up a lot in the class, is different methods of how to make decisions. And the most basic approach is to look at this as this is a type of a graph. You know, you might remember graphing from math class was mostly like drawing line graphs. But a graph is a set of connected things. And all the data that you'll see in these AI systems is stored in graphs. So they put in the system that I have all these, and then you create a way of connecting states to each other and putting information associated with those. And then that allows you to walk between the states. And you can model it different ways. One of the things you can do is to do what's called a search, which is to find maybe the cheapest way to get from one state to another, or maximize. What we really want to do is maximize the reward, the ratio of reward versus time, right? And of course these things could get more complicated. I kind of thought it would be better that I introduced it to you, because I looked at a lot of videos online. I don't know if you found one, but you found that class, so that's good. A lot of the ones I looked online, they were presented for a computer scientist who had taken a ton of math classes, and they just covered it with math. Because that not only makes the presenter look really cool, but if the audience really gets higher level math, then they'll absorb it more easily if it's presented that way. Well, I don't think it has to be that way. I don't think it has to be any more complicated than that. But the thing that in real life you don't know the probabilities going in. You think you know, but you're only guessing that it's 0.9 and 0.1. So you end up having all these question marks, and you actually discover that, and that's the training process. You'll hear a lot as you're looking at AI about training. How do you train the systems? You build it, and then you have to run information through it and train it to actually deal with this.
Right.
And that's the process of it not knowing these probabilities but determining them. learns them and collecting them up.
Okay. I understand the basic
Anyway,
concept.
yeah. So I'll leave that at then, and we'll see what more we can do to build on that. I'll see how far you go with the class as well. I might get a chance to watch some of it. Okay. So why don't we go back and see if we could do some more Python then. This over here. So where did we leave off with the program we wrote before? I think we did. Let's see if I can get it to open up. I think we were working on that, right? Okay. So I'll leave that and save as and make it. Okay. So you're still pretty comfortable with what this program did as far as the while loop?
Yeah. Well, I wouldn't. I wouldn't say I wouldn't say I understand it very well. But
well,
that's okay.
To get past that, I guess what I'm really trying to do here is to get you to feel free enough to start making changes and discovering things on your own.
Yeah.
So we will take you through a process you might try. So let's look at what changes we could make. Last time all we did was change the text just to prove that we were really making changes.
Mm-hmm.
What are some changes we could make, and then try to guess what's going to happen. And then we'll go over and run it and see what actually happens.
So I equals 0, while I is less than 5, print I equals I plus 1.
Yeah. So what is I now after that?
1.
Yeah.
And then I is 2, and then 3, and then 4, and then when it goes to 5, then it goes back to 0.
Yeah, it doesn't go back to 0 though. It's just not less than 5 anymore. So to prove that though, let's add a line down here that says print I. Okay. And what do you think that's going to do? You can just hit tab and it'll finish it for you.
One, 2, 3, 4. So after it goes through I up to 5, then it prints changing and it prints I.
Yeah, so it didn't print 0 or 5 or any of those things. So why did it print the letter I?
It printed 0 up here, right?
Yeah. So you can see what the difference is. It's in quotation marks down here and not up here. So anything in quotation marks, the computer interprets as just words.
As a text.
So you can put anything you want in there.
Uh-huh.
So a lot of times you do want something like that.
Should I take them out?
Yeah, if you take the quotation marks off, you're gonna get the number actually printed out.
Print I.
There. Okay, so I was definitely 5. What would happen?
So why is I 5?
Oh, well, so what's really happening here is it's actually changing I.
Uh-huh.
And in the computer, I is something that's stored somewhere. It's like a bank account. It has a number, and so it can be a value, but it can't be no value. And it only is going to change it if you tell it to change it. So on that line 4, you're telling it to change it. You're telling it to make itself equal to itself plus 1. But it doesn't take that to be a recursive process. Otherwise you'd be chasing your tail forever. It just says figure out what's on the right side. That's I plus 1. So on the last go round that's 4 plus 1, which is 5. Take that and then stick it into I. And then it comes back around and it says is I less than 5. It's not. So I is still 5 though, because you made it into 5. So variables have an initial value when you set them up, and then they have whatever their current value is, but they don't change unless you do something that changes them. And that's typically either they're on the left side of an equal sign or you pass them into a function. We didn't get into functions yet. Another thing that would be good to learn, look over here. Yeah, okay. If you take let's try using a function call. So you remember from math that we have functions like f of x, and that's just saying take x and run it through whatever f does. So there's functions in here, but they're not just numbers. They can do all sorts of things. There's a function called str, and what it does is takes whatever's in it and converts it into a string. A string is something in quotation marks.
Right.
So try putting I into an str. Yeah, I don't know what that's going to do. If you just do that, that's a function call, but you haven't said what to do with the results of that. So I actually want to take that function and put it into print. So functions can go into functions. The idea is that take the I, put it through the str, now it's a string. Take that and put it through print. Yeah, and then run that one. And you still just get the 5. You get 2 5s because you have the line twice in a row. So it doesn't care, because once it gets printed, it's just a string anyway. But the neat thing about having done that is now you go back into line 7 and replace the insides of this with something like I equals, notice I put that in quotation marks, so it's a string, and then plus str of I. So try putting that inside the print. Yeah, that's good. And then you just get rid of line 6 for right now because we don't need kind of 2 lines doing the same thing. Okay, yeah, run that one. Yeah, so now you're able to have a little more meaningful output because you can print multiple things on the same line. And so why did it end up coming out like that? Basically what Python's willing to do is to take 2 strings, and if you put a plus sign between them, it adds them. But of course you can't add strings because it's not numbers. So what it really does is it concatenates them, it sticks them together. And now you can put as many things in there as you want as long as they're all strings. And as they're not strings, you pass them through str and they become strings. So now you can print some more, and that's how all this is built. All these other prompts that have a lot more information, they just concatenated a bunch of stuff together. Alright, so the other thing we talked about last time is if statements, right? How you can go down 2 different paths. If we look at your current program, if I draw it as process flow. I've shown you these before, right? With the boxes and the diamonds.
Yeah.
Okay. So you're making I equal to 0, and then you're asking if I is less than 5. And if it's not, if that statement is false, then if that statement is false, then we go over here and we print I equals I. But if the statement is true, then we print I. And we make I equal to I plus 1. And then we come back around to here. And that's why we call it a while loop, because when you draw a process flow of it, you see a loop in there. So this is similar to an if statement, the diamond. And so the thing I wanted to look at next is how can we take this process and add an if statement into it, so that while we're inside the while loop, we can make some sort of a statement. I know we sort of did this before. The only variable you have is I, so the only if statement you can have is based on I. We could ask, like, if I is equal to 1, say, which will only happen once. And then we could say, if it is, we'll print something different. Let's say the word 1. And then otherwise we'll print I. And then we'll come down to the I equals I plus 1. Either way. And then we'll come back around. So this whole part here will be an if statement. So something that branches off to the side, does something, and possibly skips something is an if or an if else type thing. Okay, so to do that, I want to put this if statement at the beginning of the while before the print. So right after, yeah.
Delete all this?
Just leave that there. We're just going to add a little bit to it. That way you'll be left with all the concepts from today.
Okay.
And then you can try to build on it.
Do I add to it at the bottom or the top?
Right after line 2. So go to the end of line 2. Yeah, right in there. That's good. And then you have to be indented because you're inside the while loop. And then, so we'll put in if, and then a space, and then you put the condition there, which is I equals 1, and it has to be a double equal sign. And then you put a colon at the end after the 1. Oh, not there. Oh, you do need that colon. So you need a colon at any kind of conditional line, it always gets a colon at the end. Okay, and then if you press enter at the end of that line, it'll indent for you automatically. And then, so what we're going to do in there is just print the word 1. Okay, and then, so if that wasn't the case, then I want to still print the I as a number. And so this becomes an else. So what you do, hit enter, and then backspace 1 to get to the beginning of the line, or, yeah, and then type in else, and a colon. Okay, and press enter. and then it indents for you. And here's where I want the print I to be. So press the delete key a few times to bring the print back to where you are. Oh, maybe not like that. Or go hit down to the point where you're at the beginning of the print I. Or, yeah, right into there. Yeah, oops, sorry. And then just hit delete. And that'll back you up. Hit it a few more times. Yeah, now hit tab twice. There. So the part after the else has to be indented too. It's just whatever's indented is what will get done instead.
Mm-hmm.
Alright, so save that and run that. Okay, so it says 0 and then 1 and then 2. So it didn't print the number 1 because it was going to do one thing or the other. Okay. The other thing that we can do is we can put another if in here.
Or else print I. So it could have said I here. It says if I equals 1, then print 1.
Yeah.
Or else print I.
Yeah.
Does that mean if I was something other than 1?
It's any other case, yeah. So an if statement is like a little bit like a Venn diagram kind of thing, where one possibility was for it to be 1. The else covers all the other possible values.
Right. Okay.
So, well, let's try one more case. So, leave the else. Go to the end of line 4, I guess, and press enter there, and then back up 1, and this time type in elif, which is short for else if. Put that here. Elif is else if. And so because it's an if, that means it needs a condition. So before the colon, put a space and then another condition, such as I equals 2.
With 2 equals?
Yeah. It's always 2 equals is what we call a comparison. Compare two things. 1 equals is assignment, which changes the thing on the left side of the equal sign. Yeah, and then just press enter, and this time do print 2. Okay, and you run that, and now you'll see that it'll do 0, 1, 2, 3, 4, etc. So you can see you could do all the 5 different numbers there if you wanted. Okay. What concept should we go after next? While and if will get you through a lot of the things you need. You don't have the ability to reuse stuff. There are obviously there are easier ways to do that. You can make a list of all the numbers written out 1, 2, 3, and then you wouldn't have to have all these if statements. You could look them up. But another way to go about doing it would be to use something that's called a function. And the idea with a function is, like print and str, those are functions that someone else wrote for us, and they do a certain job. And so you don't have to write it again, you just reuse it. But to make powerful code, you have to write your own functions. So let's try making a simple function. So to do a function, all you do is def at the beginning of a line, which means to define a function, and then you put what the name of the function is going to be, and we're going to make a function that converts numbers to words. So I'll call it word for number. And then functions, notice with the functions, there's always something in parentheses. So what you do is you put, if you don't want any parameters, you don't have to. But I need to know what the number is. And number, I could call it n, I could call it I, we'll make it different just to show you. It doesn't have to be the same thing. It doesn't have to be the I. It could be something more meaningful. It could be the word number, whatever. So you do that, and then you do a colon, right? And because there's a colon, that means everything after it's going to be indented, just like any other time, and along with a colon. Okay, so let's put this as the very first line of the file.
Starting a new...
No, same file up at the very top. Yeah, so we're still, yeah, we'll keep everything we have, because we're going to use this function in the code. Yeah, so def, word for number, using the camel case style. So make the F in uppercase. Word, there should be a D, yeah. And then make the N in uppercase too. Okay, and then parentheses and oh, it's okay. Parentheses N. And then a colon. Yeah. Okay. And then you press enter. That'll indent for us. Just press enter one more time to give us a little space. And then press the up arrow. I just like to have a little space between this and the other stuff we've done. And then you hit tab to get to where you want to be. Okay. So the idea here is to write a function that will give us the word for any number. And I'll show you how to do a few of them, and maybe over the next period you can try to work on Googling how to make this function really work for any number, because there's actually a lot of different numbers out there. That would be complicated. If I gave you, you know, this number here, like that would be 1,101,000. There'd be a lot of logic to that. So for right now, we're just going to go for something similar to what you already have there.
Yeah.
Okay, so you kind of already wrote the code, but we used N instead of I. So take this part here, take this chunk of lines, and copy them. Just copy those two, I guess, and put them on line 2 there. Yeah. And then notice that when you pasted, you were already indented, but it was already indented. Anyway,
Yeah.
so it doubled up on you, but that's okay. And then it has to be N instead of I, because we chose to make it N. So just change the 2 I's into an N.
I here?
Yeah, right here. Okay. And then, so notice like here, we effectively declared this variable by giving it a value.
Yeah.
Here, because it's a parameter, that's why it exists inside of here. If you use like a J there or something, you get a runtime error and say you're using an unknown variable. So, so there was 2, I think you see how you could do any number of them that way, if you wanted. But there's probably always going to be a case where you don't know what the number is. So let's go right there. Let's do another else. And then on the next line, we're going to handle any other case which will be unknown because we don't know. But what's distinct about a function is you could print in a function, but usually functions figure things out for you. The print function is sort of special, but like the str function, it figures out how to convert a number into a string. So we don't want this function to print for us. We want it to figure the word out and give it back to us. So rather than printing it, we're going to return it. And the way you do that is just with a return statement. So type in return and a space, and then in quotation marks put unknown. Yeah, and then, so I want to change these two to work that way as well. So it's going to be return 1 and return 2. Yeah, and then it's sort of a unique case. It doesn't have the parentheses either, because return isn't a function, it's a keyword. So it has to be just return space and then, yeah, no parentheses. Okay, so now you have your own function. So do you see where you could use it?
Tell me.
Okay, let's try, we're already printing them in here. Let's just do it down here, I guess. Try print, and then in parentheses put word for number.
Do I need to do it with this?
Now here, notice how it's offering to complete it for you?
Yeah.
You could just hit tab, and it would do it. You also, I think this will work, if you had just typed in, notice word for number is camel cased. Well, it understands it. That's one of the key reasons to use the camel case is it's to you an acronym. Now you hit tab, and so you don't have to type those things out, but the first time. But now the code is much more readable. So, and that's a thing you can read more about. But really good code nowadays is considered self-documenting, because you can write comments afterwards to tell yourself what the code does. But no one ever gets around to having the time to write as many as they want. If you choose good variable names and put in a lot of functions, then anybody can look at the code. You can look at your own code and say, oh, I get what that does. So if you don't take the time to make your code self-documenting, you're probably not going to document it either because you don't care. I mean, it works at the time, but bad in the long run. So anyway, but it's a function, right? So a function always takes something in parentheses. Even if it was a function that didn't need any parameters, it would still take the parentheses. Anyway, so in the parentheses, you could put any number you want, but try putting a 1. Yeah, just save that and run that, and I imagine you realize what's going to happen. But so now you have 1. So now, I was going to leave this for you to play with, but you could come in here and get rid of those. You don't need that anymore. You can just call word for number. And so now you can, maybe you didn't need this particular function, but by adding a function, you can then sometimes reuse it hundreds of times. And also, a lot of this stuff...
And it already knows how to spell all the letters? I mean, all the numbers?
No. Someone else has probably written a function to do it. That's where the great thing about Python is there's so much free code. But you could write your own to do.
So if I said 55, it might not know that, or it might.
We'll give it a try. So why did it say unknown?
Because it doesn't know that number?
Yeah, logically, but I mean, technically, why?
Because I haven't typed it in there?
I mean, the unknown comes from here. Right there. So you're right, it doesn't know the number, but it's because it went through these two if statements, it got to the end, and we decided to make it return unknown. So it only knows 1 and 2, so those are the only numbers it's ever gonna.
Because that's the only ones I've typed in?
It's ever gonna know, yeah.
So I have to type in the numbers by hand.
Yeah, obviously it would be pretty inefficient to try to type in all of the infinite number of possible numbers. So you need an algorithm ultimately to do all of them.
Yeah. Well, time's almost
a little
up.
harder, but
yeah, you know, in terms of thinking about how to go about AI, like, I don't know, in 5 or 10 years from now, there's going to be so much information. Basically, the only relevant program is going to be somehow managing all these different huge systems, like an AI program that can go to Google and look up something, do a search on the engine, and then bring back the result, and then use it to, I don't know, go into Amazon. Anyway, like somehow just sort of managing all these huge systems.
Yeah, it's really about dealing with information. We're putting more and more information online, and the rate at which we're acquiring information is an exponential rise. So it's getting ahead of us faster and faster. And that's why the AI push is so huge, because there's this great value of data. The data is worth more than all the billions of dollars floating around,
Yeah.
but only if you can leverage it.
Yeah.
And it's about using that data to make better decisions. I was joking with
Yeah. That. I guess. Yeah.
that
It's
was
not,
why
which
I
is not
wanted
hard to
start
make it.
with that, because this is what I know you're really wanting to think about. Whenever I put that. I didn't even write the name of it. What was I doing? Markov decision process. This, you will realize in the end, is a gross simplification of what you really want to do.
Yeah.
It's just it's a hello world to AI, I guess.
So. Yeah.
Yes, you have the
If I can
exact
just-
steps now, so do you know how to, confident you know how to do that now?
I hope so.
Start a terminal, type those things in.
Yeah. Well, I understand them a little better now.
Yeah.
Like it was just over my head last time, but I'm getting the concepts, and that's, you
You
know,
got a working computer now, that's good.
yeah, one step at a time. I'm coming up.